These sort of straight line vector proofs always revolve around the idea that we want to show the smaller vector, so MP, is going to be some sort of multiple of the longer one, mn. Let's see what we can do then. So if we start off by labelling what we've got O to A is vector A, and O to B is vector B. So I'm going to put in here B. We're also given M is the midpoint of OB. So I can actually go ahead and add O to M. It's just a half B. And I'll make it really clear. This is for OM, and I'll put OB here as vector B. So we're not getting confused between this just being our half and this being our full thing. So our next step then is we've got A to P is KA to B. So that's this small vector in here. But actually we don't know at the moment vector AB, so let's work that out first. So vector AB, or to go from A to B, you're going to have to go from A back to O, and then from O to B. So A back to O is minus A in the opposite direction. And then from O to B is just vector B, isn't it? So minus A plus B. Using this fact then, well, we can say that means A to P is going to be K minus A plus B. And something we should be thinking about here is, of course, A to P is shorter than A to B, so K we're expecting some number that's between 0 and 1. Let's go on to the main part of this proof then. Well, we want to find the vector M to P first of all, because that's one of our parallel vectors. So let's think about how we go from M to P. And our route from M to P, we're going to have to go from M to O, O to A, and A to P. So from M to O will be minus a half B. From O to A is just vector A. And then from A to P, this is going to be our K brackets minus A plus B. So plus K minus A plus B. And at this point, let's sort this vector out, make it look a bit nicer. So in terms of our A's, we've got a 1 from this A, and we've got a minus K. So we've got 1 minus KA, and then in terms of our B's, well, we had minus a half B, and we've got plus a KB. So we've got K minus a half B for our MP. That's one of our vectors sorted out then. We'd also like to find the vector M to N, because that's going to be parallel with this vector. So let's next look for vector Mn. And to go from M to N, it's actually a little bit easier. We go from M to O first of all, so that's minus a half B. And then we go from O all the way up to N. And we have to use this fact to help us. AN is 2OA. So if OA was just an A vector, well then this part here, AN, will be 2A. And that means in total, to go from O to N, we've got 3 A's, haven't we? So minus a half B plus 3A. So here's the big ideas about vectors that are starting to culminate. What we're saying is that this vector MP, if we multiply it by some number, we'll get our vector Mn. That means that these will form a straight line. They're parallel with each other and they have a common point of M. Let's express this in a slightly different way then. So what we're saying is that, and writing this the other way round, we'll write our A first to be nicer. So 3A minus a half B, just to make that Mn a bit clearer. What we're saying is that if we take 3A minus a half B and we multiplied it by some number, well then we'd get our 1 minus Ka plus K minus a half B. Yeah, so this was vector Mn, this was vector Mp, claim is that these are scalar multiples of one another. Something really important to appreciate then if they're scalar multiples is that the ratio of 1 minus k to 3 should be equal to the ratio of k minus a half to minus a half. The ratio of the a's should be the same as the ratio of the b's. Let's write this a little bit differently and more helpfully as a fraction instead. So what I'm claiming is that 1 minus k over 3, in other words, the ratio of the a vectors, must be equal to k minus a half over minus a half. That's the ratio of the b vectors. This equation is what's really important because it's going to tell us the value of k in a moment. To find the value of k then, we should be first of all cross-multiplying to get rid of any nasty denominators. So I'm going to have a minus a half coming over to this side. So minus a half brackets 1 minus k. And on the right-hand side, the 3 is coming up to give us 3 brackets k minus a half. I'm just going to pop over to this side of the board so that I'm not stood right in the corner. To make this a little bit nicer to expand, let's get rid of the minus sign first, and that will actually flip. Instead of here 1 minus k, we'll have a k minus 1. So I'm going to write a half brackets k minus 1 equals, expanding these brackets, we'll have 3k minus 3 over 2. Minus 3 over 2. Let's expand this side now, so we have a half k minus a half equals our 3k minus 3 over 2. And solving for k, we're going to take away a half k from both sides. So that will leave us with a 2.5k. So 3 minus the half. And being careful with minus signs, we've got minus a half plus 3 over 2. So we should end up with just a plus 1 here. So the very last step, 2.5k is 1. So dividing both sides by 2.5, we should end up with k is equal to 0.4. And then we're done on the question.